Good evening. Welcome to BayPIGgies. Happy Free Software Day. Tonight's speaker is Mike Pittaro. We're going to get an overview of what it takes to develop a product in Python. We can go late. I hope that this will work for you. Ask questions, and at the end we'll have our normal random access and mapping, but it might be a little tight. If anybody has got ideas for future talks, please come and see me. My name is Jim. You're on. Ice cream. Oh yeah. Yeah, ice cream. They got free ice cream in the back. Don't miss out. Ben and Jerry's.
Okay. Save one for me. So good evening, everybody. Volume sounds good to me, so let me know if I start droning off during the talk. I have a tendency to let the volume drop. Thanks for having me here, and thanks for Jim for helping coordinate this. He went through the painful review of, I think, what was 100 slides before we kind of pared it down to what I thought would be a reasonable talk. So tonight, what I'm going to talk about is something a little less technical than I think some of the other talks we've had here. It's more, I think Jim built it right when he said it's a soup to nuts discussion of an open source project I founded back at the end of 2005 to build a fairly substantial product based on Python. So we're going to be covering some of the things we found both in terms of the project and Python and some of the infrastructure we built out. In terms of timing, I have a feeling it's going to take me almost an hour to get through all the slides. It's pretty dense. I'll try not to rush. I think in terms of Q&A, a good approach is I'll try and do things interactively, but if we start going down rat holes, we'll have to stop and keep moving unless we really want to pursue that path. The downside to that approach is I think almost every slide in this presentation will eventually lead us down a rat hole because a lot of the stuff we touch are very much our decisions, some of the things we did which may or may not be right, and I'm also interested in feedback on some of that stuff. So I think a quick place to start here would be to discuss what the product is or what the project was. I started this project at the tail end of 2005, and it's a data integration framework implemented under the open source model. The goal of this project was to simplify the problems people have with data access and data transformation. In the data warehousing world, I like to call this ETL. If you go more to the kind of the day-to-day practitioner world, I think Greg Wilson called it data munging. He wrote a book on it. It's people that are just trying to get data from A to B. And you know, a lot of us write these point-to-point programs, but it'd be nice if there was a better framework to help orchestrate this. One of the things we did in this system in terms of both scalability and some other reasons is we built it on a REST architecture, which is very similar to the way the web works. And that both raises some challenge and gives us some very nice capabilities. The goals of the system were to make it scalable in terms of performance and also in terms of connectivity, the ability to build extra components and extra transformations. So scalable and extensible, and I put in parentheses here by an ordinary developer. We wanted somebody that's a reasonable Python programmer to be able to write a driver for an application or a database without having to jump through hoops. The other point is it's meant to be easier than writing custom code for every interface. I think the first time you use it, it's not going to be a lot easier than just going back to your old tools and just writing a custom piece of code. But over time, as you start to build up components and reuse things, you can get a lot of leverage from the system. An interesting decision is traditionally, in particularly the data warehousing industry, things are targeted at business users because they pay a lot of money for the software. I felt that it made sense to try and target the product more at a developer because in reality, developers are the people who end up doing this data integration work at the back end of the systems. You know, often a big transaction is done with an executive, but it's a developer that has to use the product. And something else that's really been coming up a lot more since we started this project is a trend where people are trying to access both web data and their local relational database data or file data. So the general notion of having data at an HTTP endpoint to pull it into either a data mashup or a web-style mashup is becoming increasingly important. I'm tossing up a block diagram here. I apologize, some of the fonts here are kind of small. And I'm not going to try and beat this diagram to death. What I wanted to do was touch on the nature of the product to give you an idea of the scope of what we're building more so than get into the internals of it. The core of the system is a data server that has a series of components, all written in Python, which implement both connectivity to the outside world, database read, database write, things like RSS read and write, and also transformations. There are aggregators, sorters, and so on, and these are built as components inside the server. There's a special component in there I call the pipeline component, and the job of the pipeline component is to let us assemble instances of these other components at runtime to build up these streaming transformations so that you can fire off a database read, and then as the data becomes available, pipe it into some sort of computation, and then pipe it into a sort, maybe pipe it into an aggregator and down the line. So that's pretty much the job of the server. At the lowest levels of the server, there's a data store based on RDF, the semantic web technology, and we use that to store definitions that a user has created of these various transformations. And then there's a front end here, which is an HTTP listener and dispatcher that pretty much takes requests into the server and then decides, based on a resource definition, how to dispatch it to the right component. Outside the server, there are a whole bunch of supporting tools that help us deal with that server. There's a command line interface that's used to go into the server and kind of initialize the repository, set up some of the security and permissions and things like that. It's not too sophisticated. In terms of defining those resources, there's a client tool that runs in a browser. This is actually Flex Ajax-style client UI. And that connects to an intermediate server we call the management server. And it uses XML RPC to talk to the management server. The management server, in turn, talks to the back-end data server to load and save the definitions of those resources. In addition to having that whiz-bang UI that lets you kind of draw things and look and create your pipelines, there's an alternative interface using Python directly where you can write programs using a module called SnapScript, and you can actually create those definitions and save them on the server, or you can actually fetch the definitions from the server, modify them, and save them back. This was something I wanted in the product from the very beginning. I've worked with a lot of GUI tools, and there are some really, really nice design environments, but I've always felt that it's also nice to have that other path where, rather than navigating through many screens in a user interface, sometimes it's nice to just go in, fetch the object you wanted to modify, make the changes to it, and save it back. Sometimes that's quicker. And then another aspect of the system is we can actually have data servers that connect to other SnapLogic servers to deal with both data parallelism and just kind of a wide area data transformation problem. So I think in summary, the reason I tossed up this picture is to give you an idea of the scope. It was a pretty big project when we started off. I have to admit, when we started, it wasn't this big, so it got bigger as we went along. But it's pretty audacious to try and do this from scratch as an open source project. Which raises the first topic I thought would be worthy of some discussion. So I cooked up this crazy idea that I wanted to build a system. And the first thing is, OK, I need to get some programmers. So we now tried to find some Python developers. And I think what I found is hiring Python developers is difficult. We're still hiring if anybody's interested. I found it was very hard to find a Python skill set if I looked for it specifically. I did try the BayPIGgies list earlier this year. I think it was January 2007. I kicked out an email. I think it met the list guidelines. In any case, it triggered a discussion about whether or not job postings should be on the list. It triggered a discussion about a name change. I don't know what it is about BayPIGgies. It's something to do with Kennedy, I think. There was a meta-list discussion. There might have been a list split. I don't know if that actually happened or not. There was. But at the end of the day, I never got a reply back. So that didn't work. I think another aspect is we're a startup. We're a small company. We don't have an established business model. We don't have an established customer base. There is a risk factor. I think what we've learned since then is it just seems to be better to hire good programmers. Don't even get hung up on the Python thing. Look for good programmers. Look for good software engineers. I think from experience, good developers can use any programming language. There's this religious aspect that I think we can convert them to Python. Most people get Python, and if they're smart, they seem to get it pretty quickly. One thing to watch for is I think it takes a couple of months for the real Pythonista mindset to sink in. The people I've hired are very experienced, and some of the guys I have are experienced in parallel programming, GIL issues aside. They're familiar with C, they're familiar with assembler and machine architecture. They pick up Python pretty quickly. it hasn't really been a limitation. Also, Python seems to have that secret weapon thing going on where it's used a lot, but people don't actively advertise that they're Python developers. I've never figured out why. So I think the lesson we learned there was don't go specifically after Python people, just look for good developers. And of course, classic, friend of a friend referrals are the best way to get people on board. So once we had a couple of people on board, we started working on the system. And we really started with a prototype. There were lots of ideas. We needed to prove some concepts. There were some ideas in here that definitely challenged established norms in the way the data integration process is done. We were modeling data as a REST resource. We were streaming data through pipelines. And one of the things we had to figure out is how do we store these definitions and make them fairly accessible. So we started the prototype in, I think it was March 2006. We'd been playing with some stuff before then. And we started with Python. We needed an HTTP server, so we used CherryPy. It was the one that most directly suited our needs in terms of making HTTP disappear so we could work on the real issues. We wanted to leverage as much as possible from available code, basically build upon the existing libraries. And we didn't have a strong bias towards the final decisions. This really was intended to be a prototype. And I think it was successful. We proved the concepts. We came up with answers for some of these tough problems. And in the process, we learned quite a bit about Python and the larger Python community. I think since then, the Python community is becoming more publicly visible. You know, the advocacy efforts are paying off, and people are more aware of it. We did make a decision I think is worth discussing, which is why did we use Python for the prototype? And there are a couple of reasons. I think the main reason was the rapid development. We wanted to prove the concepts quickly. I think with Python, when you start working on something from scratch, you get working code sooner. You play with it. After you've played with it, you kind of into it for a couple of days with running code, and then you turn around and you say, I painted myself in the corner. Throw it away, go back, revisit the design, you know, based on what you learned. So really, you get to the point where you start identifying the essential complexity without getting hung up in the tool chain. Before I was using Python, I did most of my work in C. I'll admit to a little Fortran. And I think the difference with C was you spent a lot more time thinking and designing than you did writing code. Then you finally got to the point where you started writing the code, you debug the code, and then you get it up and running and you realize I did this wrong. The trouble is you're out of time. You know, you did it wrong, you screwed up, maybe you'll do it better next time, but you're out of time and you literally have to deal with what you have and make it work. We didn't have that problem with Python. Another aspect was readable code. It was, given that it was a startup and we were trying to recruit a team, I felt that having some readable code that people could look at and understand was essential to kind of build the team and get that community ethic together. We also wanted the ability to study what we'd done and what we'd thrown away. You know, we don't want to reinvent the wheel. And it seems that that readable code really helps when you bring a new developer on board. They grok it pretty quickly. They get in there, they start looking at it, things make sense to them. I also had a hidden agenda here, so when we were starting the project, I used to work with this guy named Tim. And back in 1992, he was one of the early Python users, and he said, this is a really good programming language. I ignored his advice for 15 years. I really wasn't using Python. I've seen the error in my ways. And one of the things I wanted to see was whether I could use Python to build a substantial system. I'd used a lot of Python in terms of gluing A to B, web scraping, kind of back-end stuff, but I'd never really built anything substantial in Python. Coming out of the prototype, what I've done on this page is kind of tried to put together a list of the sort of core technologies we were using and what we found as we went through the process. One of the things we needed was just basic libraries. I think the concept of batteries included. The Python standard library has almost everything we need. There isn't really much fundamental capabilities that you won't find either in the language or in the standard library. For an HTTP server, I think it's the other extreme. There are a bunch of HTTP servers. So we saw CherryPy as a kind of HTTP server and application framework. There's base HTTP server in the library. There's the twisted framework, a lot of other choices. So we actually had to do extra work there to decide what to do. On the database connectivity side, there's the Python database API. Pretty good API. Doesn't have modules for every database yet, but it is getting better. We had a requirement for a compact data encoding between these stages in our pipelines. We needed to compress data down to a fairly small format. We decided on PyASN1. This is ASN1 is an old telco wire level formatting protocol. It takes numbers and characters and it just packs them down into the minimum number of bytes. It's very efficient without getting down to compression. And this is because we move a record-oriented format in our pipelines. We don't really move like XML documents. For RSS and Atom, which were clearly staring us in the face as something we would have to work with, there's the feed parser library. It's just a good library that parses. It doesn't write, but it does a really good job of parsing. For the resource definitions that we needed and the resource database at the back end, we had done some homework, and eventually we settled on using RDF, and there's a really good RDF implementation in Python called RDF-lib. So that gave us a way of having both the resource definitions and converting them to and from XML. It gave us some query functionality, and it gave us a data store at the back end. RDF-lib at the back end, it supports SQLite, MySQL, and Berkeley DB. So between those three, we got some pretty good choices. For error and activity logging, which you need to worry about in any substantial project, there's a logging package in Python. You can debate whether or not you could write a better logger, but the reality is it's a pretty full-featured logging package. So you spend a little time tweaking and customizing it, and you have error logging. We needed a command line tool. I mentioned that snap admin utility. There's a command package in the standard library that'll help you write a command line utility. For plugins, we wanted these components to be plugins into the server. They're currently not dynamic. They kind of get loaded at startup time, but we needed a way of having these plugin modules. It was basically a little bit of wrapper code around modules, packages, and the import statement. We did not need to reinvent the wheel in terms of coming up with some plugin mechanism. It's already there, and it's very accessible if you want to customize it. For a configuration file, the first cut was literally a Python class that we would import that had the various values in it. And I actually kind of like that, but I was shot down, and we later switched over to a more formal configuration file using config parser. And that's worked out. Again, it wasn't a lot of work to deal with. I think the downside of using config parser versus import is you don't have to parse anything if you import. The downside to import is somebody screws up the config file, you start throwing exceptions. So there are trade-offs, but both of those served us well. So we found a lot of things that we could leverage. We also found some issues in the prototype that were the essential complexity that we had to address. One of the decisions we made was to write yet another HTTP server. And there was a reason for it, though. In the first cut, we built our own HTTP server, and the reason was we looked at Cherry Pie, we looked at Twisted. Twisted, very interesting, but the learning curve looked pretty daunting from where we were standing, so we weren't ready to go down that path. We looked at the base HTTP server, we looked at Paste, we looked at Mod Python, Mod WSGI, and I think the big issue we were bumping into was all the existing HTTP servers implement HTTP as a request response, but each of those, whether it's the request or response, they typically treat it as a header plus a message body. And on the application side, if it's an HTTP GET, the server gets the headers and it gets the message body passed into the request, and the entire request is made available to the app. We wanted to stream data. So we wanted to have a model where we could get the HTTP headers and the HTTP requests, quickly scan those to decide what to do with the data, and then take that data stream and hand it off to the component that was actually going to consume the data, assuming there were no critical errors in the payload. So that requirement was kind of unique, and it more or less drove us to at least write our own HTTP server because it was a showstopper issue. We ended up with, I did a count here. I went back into Subversion and did a count. We had about 440 lines of code, 520 lines of comments in docstring, because the guy that wrote it really liked to comment his code, and he really wanted to explain what the issues were that he was dealing with in there. But it literally took days, not weeks. We were able to get an HTTP server up and running, and I want to make it clear, we did not implement Apache in Python. This is not a full-featured HTTP server. It was a very limited purpose thing to help us address this issue of being able to take a request, read the headers, and then literally pass the data stream to another component in the code. So that was an interesting experience. The code's there. We will, I think, at some stage replace this with something else, probably WSGI. Something else I think is worth mentioning, at least in the startup environment, is kind of tools of the trade, what the work environment is like. In terms of basic tools, we were building up startup infrastructure. So we got a Unix box. We brought up a Unix server with Samba shares for people that were running Windows, IMAP server, POP, SMTP. We set up Mailman for an internal mailing list, so we archived our discussions. Subversion for the code. We started off with Track for a basic bug system. We were using Moin Moin as our early wiki. And most of this infrastructure got built up pretty quickly. It wasn't real hard, and you can kind of deal with the care and feeding ongoing. It's not heavy administrative overhead. On the desktop, we're still a mixture of Windows and Unix. I think Ubuntu seems to be gaining ground among everybody. I'm still the Mandriva user. But there's still a couple of guys that use Windows, and we have no rules saying you will use Windows, you will use the Mac. We don't care. You're writing code. Use the tools that suit you. In terms of day-to-day activities, there are basically two camps. There's people like me that work at the command line with a text editor. So it's VI in my case, or Vim, and Emacs. We've got a group of people like that. And then I think the other half of the team really likes this Eclipse PyDev environment. I don't do good with IDEs, so I don't really use Eclipse or PyDev, but I can see there are some cool features with source code integration and so on. On the Mac, I recently cut over to a MacBook, and I've been using Komodo on the Mac. And I don't know how to put this. It's not that I don't like it. I just find that whenever I fire up one of these IDEs, it doesn't really make me more productive. I find Komodo pretty useful for showing people code and giving demos where they want to get into the code because it gives you a nice layout, and they can't deal with me just flipping windows and command prompts quickly. So Komodo's good for that. It also does a pretty good job at debugging threaded Python code. I think the alternative is Wing, and Wing really can't handle threading. So I still have it installed, but it's not my main development tool. In terms of development methodology and engineering practices, on the process side, if you put us on the capability maturity model, we're probably level 1, level 2. We're getting better, and we just hired a really great software engineering director that's going to get us into shape on the process side. But we're not real strong on the process level yet. In terms of day-to-day practicalities, we're operating from the Joel test. How many people have seen the Joel test? Okay, so everybody knows what I'm talking about. I put us somewhere between 11 and 12. So the half point is actually two different topics. I think the half point is, Joel says you should have the best tools money can buy. We have the best tools that we can afford. It's probably a little bit of that. And I think the other aspect is when it comes to usability testing, we do hallway usability testing, but it's with the engineering team. So that doesn't always mean you get really good usability testing yet. But to me, the important thing about the Joel test is it hits the high points, which are, do you have a spec? Do you have a bug tracking system? Do you have source code control? We found very early on, just get that stuff in place. Even in the very earliest days of the prototype, I think the first time a zip file went through email saying, here's the code I was working on in the weekend, Subversion was up the following day. I just didn't want to do that anymore because even if you're checking into a private branch or whatever, you don't want to have code in email. So we did that. I think we did that right. It's paid off because we're not going back and rebuilding infrastructure now. Now we play a little Jeopardy. So one of the topics in terms of Jeopardy is, if you look at an answer and you say, this is toxic waste, the question is, what is the question? And we discussed this thing we call toxic waste, which is open source bug fixes. Not open source bugs, but bug fixes. Really what this is the crux of what I think drives a lot of the open source community. We're working with a lot of third-party packages. We're working with database drivers. We're working with Track. We're working with PySQLite and so on. There's a lot of moving parts here. We found bugs in some of those packages. What are you going to do? You find a bug. Well, since it's all in Python, you've got the source code. We went off. We fixed the bugs. And then you're in this kind of dilemma. OK, we did a bug fix. The bug fix looks good. By the time you debug it, you pretty much know what the fix is. So you're pretty sure you've got a fix. It may not be the final fix. It may not be the one the code owner would have set, but at least it's probably a fix that demonstrates what would work. So now we got this custom patch. The last thing we want to do is keep it in the facility. So we treat it as toxic waste. We basically take whatever we have, and we file a bug report immediately. In most cases, when we file a bug report, we're filing the bug report with a test case. I think in the vast majority of cases, we filed it with a test case and a fix. No surprise here, but on any open source project, if you provide a fix, the probability of that fix being checked into the core code is much, much higher. Test case and a fix helps. The other options were, if we had a custom patch version of something, we don't want to redistribute it. There's licensing issues that come up, and the lawyers have to get involved, and you don't want to deal with that. But more importantly, you now have some sort of fork off some other open source project. You don't want to maintain it. We actually check them into a version and keep them there just in case, but we don't want to maintain them. We could monkey patch. We don't want to monkey patch either. So we'll save that for an extreme case, but we really don't want to do it.
I have a question about your previous slide about the Joel test. You mentioned about one-click build system deploy thing. What did you guys use?
I think it's about 10 slides ahead.
Okay.
So we're going to get there. I don't think it's quite one click, but it's real close. I think it's one click and a whole bunch of other things happen. But, and then another thing to mention, in like 2 years on this project plus 5 years of pretty steady Python using, we really haven't found a core Python bug, either in the language or in the standard library. The closest thing I've come to that is where I have code that doesn't work and I find out it's some problem in the Python 2.3 libraries that's been fixed in 2.4 and fixed in 2.5, and it's really not an issue. So yeah, in the older versions we found issues, but usually they've been long fixed by the time we've stumbled across them. I mentioned this a couple of times, but I think there's a good story around SnapAdmin. Working with our server, we needed a command line utility that was just there as a basic get into the server, do some basic operations before the whole framework was up. So there was some server management stuff. There was a couple of magic commands you need to do to initialize that resource repository and put credentials in it. Some user and security management stuff to bring up the server. And also we wanted to have a command line import-export functionality for these resource definitions. We ended up using the standard command package, which is in the Python library. It's fairly easy to use. I think in terms of implementations, I said here command prefers a noun-verb syntax so that your commands tend to read resource import versus import resource. There's probably another case to be made that I prefer to implement it that way. But the way the command package works is it parses a command line. It takes the first token and then dispatches to a class based on that token, and then that class in turn can process the rest of the command line. So I think naturally it tends to fit into this model where you have an object that does all the resource commands, be they import or export, as opposed to an object that implements the import command for many other things. Also, this isn't a major user interface, so the kind of awkward backward syntax was reasonable in this case. Again, we could always revisit it, but we wrote this thing in days, not weeks. So, the first cut was up in like a weekend, and then during the following week it got fleshed out with a whole bunch of commands, and it had built-in help. It had, it's got read line functionality, so it has command line completion, it has command line history. I mean, all that stuff came for free, so it was worth using it. The interesting part of the story here is when we first started talking about this, somebody dusted off an old command line utility they had in C and kind of ported it over to Python. So one of the guys was writing a command line parser that did a read line, break it into tokens, start dispatching commands based on that, basically the way you do it in C. And I think the moral of the story there is, it helps to know what's in the library. So you really need to print out a copy of the Python library reference, keep it lying around. Every time I look at it, I find something I didn't know was in there. And I've been through it quite a few times, and I still keep going back. I don't know if they keep adding more, or if it's just me, which they do keep adding more. But more importantly, I think there's always something that's been in there for a while I didn't know about. There's a comment at the beginning of the reference manual that says, keep it under your pillow. That's very good advice. It really helps. There was another aspect of the project that I think comes up here, which is getting into more advanced Python. I think, Alex, you call this the level where you go from getting from the basics to detached to transcend last night. But one of the things we did was create this library called SnapScript. And I think the motivations are a little tricky unless you really understand how snap logic works. So I'll try and explain this as clearly as I can. Within the system, there's one object, which is the resource definition we call resdef. And it's a pretty complicated object. It's the basis for all the resource definitions. There's a lot of RDF5 and graph code in there. And the interface to this class really does require some knowledge of the system. It's pretty much an internal object. The trouble is we were going to use this object to let people use that programmer interface where they could create their own resource definitions. Not a good idea. This thing was really complex. So we really needed a simpler interface. This is for programmers defining resources and just using predefined things in the system. So we came up with this Python package we call SnapScript, and it's a set of generic classes that encapsulate the ResDef object. So they give you a very simple interface to the resources. The interface at this level is very much a get and set property. And effectively, they hide the internal details of that ResDef. And we did this at a deeper level by starting to use setAttr and getAttr to do some interesting hooks on customizing attribute access. There's a section in the language reference manual. There's a chapter in there on customizing attribute access, and then there's a similar chapter in Python in the Nutshell. And between those two and the cookbook and a couple of late nights, I think I figured out how to do this. But it took some serious homework, but at the end of the day, it wasn't that hard to do. I think the best way to describe this, and also this is the BayPIGgies, so I do have to show some code here. So best way to describe this is to compare the two classes of code. So this is a ResDef code sample, and it's going to create a database read resource. So at the top, we have a bunch of imports at the top. And then the first thing I'm doing here, I should put line numbers here. I'm learning. Next time I'll put line numbers. So the first thing I do is I call the ResDef class, and I call this getResDef factory function. I pass it the dotted path name of the module that implements the thing I want. In this case, it was a DB read. And it's going to give me back a reference to R, which is a specific instance of a DB read ResDef. I then go through and I set some properties. The thing has a URI, which describes where it fits in our web space. It has a description property, so I call set property on description. I call set property on title. I call set property to give it a database connection, and this is actually a URL reference to a connection. It has a SQL statement, so I type in, I cut the SQL here, it was much longer. But I create the SQL, and I assign that using a set property again, saying the SQL statement. I then create something we call a view in our terminology, which is basically a record definition. And I call the special list property. So I go off here, and I take this view, which is in this case, we use tuples for views. It's one of the things I love about Python. For some of these things that are record definitions, it's just so easy to type these into code. It's even better if you have to scrape them off a web page that you can write a piece of code to scrape these things, convert this definition, and paste it into your code, or create it dynamically. But again, we go in and we set this list property. This is the type of list property. I'm sorry, this is the name of the list property. This was the type of list property, which is a reference to list types from the module, and this is the actual view definition. So it's not a real clean interface. In retrospect, we could have done this better. But it's not a perfect interface, and it is what it is right now. We'll come back and revisit it. In the alternative universe with this SnapScript module, the interface is much friendlier. So you start off, and at the top, you basically import the SnapScript module. And then to create a resource, you basically create a SnapScript resource by calling the constructor. And again, you do have to pass in the dotted path name of the component. I couldn't find a way around that time elegantly. But once you've done that, you get a reference to a very generic resource object in SnapScript. Once you have that object, you manipulate it by assigning to members. So within the resource, I set props.uri to the URL. I set props.description. I set props.title. I set props.dbconnect. I set props.SQL statement. So they're direct assignments to members in the object. And behind the scenes, we're just using setAttr and getAttr to go off and do the right thing. And what that right thing really involves taking these strings and, again, making those set property calls we saw in the previous example. But a user at this level never knows that. Some of the cooler things we could do when I talk about the view is when we assign to properties here in a view, we've set things up so the properties already has a member in it called output view, which is one of those predefined view types. So I can take my list of tuples here, and I can assign them directly to props.outputView.output. And this is where things got tricky, because this is the view definition in Python. This actually becomes the name of the view. So when I type in output in the Python code, very naturally, that actually becomes the name. If I went back to the previous slide, over here, actually, it's a typo. First time through the presentation. This name that's in here where it says input view, in the In the alternative code, that's actually figured out by just using it as the name of the attribute in Python. So you avoid a lot of the quoting and the code becomes much cleaner. And the way we did this was the props member on this object is hooked by setAttr and getAttr. And as the assignments happen, we go into some custom code that just does the magic behind the scenes.
So the attributes you're setting there, those aren't static, they're not discoverable at all, they're all dynamic.
Everything under props is dynamic, so that we kind of put in that intermediate step in there called props to be the properties. And one of the reasons is within SnapScript, depending on the code you're writing, sometimes it's nice to be able to add other attributes to the SnapScript object, and we didn't want to restrict that. So I hung them off kind of a sub-member just to put them at a level down. But in terms of the property names here, like title, dbconnect, SQL statement, they're actually defined by the DB read. And when you're doing these assignments, we do check the names and make sure you've typed in the name right. But it just seemed, and we raised proper attribute name exceptions. So the intent was to let you just type the code without having to put quotes around things and just make the code natural. But they're still validated behind the scenes to make sure, like for example, if you try to assign to SQL statement in something that's not a DB read, it won't work.
Right. I'm just asking if the actual attributes are discoverable. Like if you do dir on the props object, you actually see all of the available assignments.
Oh, I see what you mean. They used to be. I haven't done it in a while. So I think if you do dir, they don't appear. But if you call stir to get a string representation, stir actually makes it look like they're there. I don't think if you go in and do dir, I don't think it'll see them. I'd actually have to go check the code, or you can go check the code if anybody's. But I don't think we properly squeezed them into dir. I think that's the trade-off. If I were to able to use the property function to get and set the properties, it would have been a little cleaner. So this is where we got a little deeper into some of the Python aspects. I mean, this was hard research. The code was not hard. Another aspect of an open source project, people are going to see your code. So as we were moving through the project and we were playing with Python and doing all this research and stuff, I think one day everybody woke up and said, uh-oh, you know, this code's going to be public. People are going to see it. We've released it under a GPL version 2 open source license. And that means, you know, the code's out there on the web. People can download it. People can see it. So it really drove a cleanup phase. Yeah?
Version 2 and later, or version 2 only?
Right now, version 2 only. We were on the line between version 2 and version 3. Version 3 wasn't final. We just decided to go with, and the trouble with the version 3 not being final is you don't know what you're signing up for. So we just decided go with V2. We'll come back and revisit it later. But the real driving issue here wasn't just the open source license per se, although that was a hassle because we had to go put license tags in all the code. It was really just the issue of, you know, it's cleanup time. And you've been kind of playing with all this stuff for a while, and suddenly you realize, small team, we need to do some code cleanup. So we needed to go back and revisit a lot of the module and package structure just in our tree. So we ended up with top-level directories that have the data server, the components. There's a utils directory, which is common code that's shared in the system. And then there's a separate directory for the SnapScript object. So this let us break up some of the dependencies and really kind of forced us into a discipline. It also simplifies development. There's only half a dozen of us working on this, so it's not like we have huge issues with people stepping on each other. But the system's getting bigger, and you have to worry about that. Something else is we did put a lot of code in, a lot of documentation as the code as we went along. We just weren't consistent about a discipline and how to do that. So there was good documentation, but there were comments in there. There were doc strings in there. There were just huge, long, triple quoted strings in the middle of functions that arguably should be comments from a style perspective. So we went back and tidied a lot of that stuff up. What I found helped is we standardized on using epidoc to start creating the docs, and we just set up as part of the build process. We run epidocs, we generate the API docs for all the class interfaces, and suddenly you start seeing problems. Like you see modules that don't have a doc string, you see modules that have a doc string equal to the subversion ID, and so on. And the code owner did the documentation, so whoever owned the code. It's not like we were able to go get other people to go document people's code. We just tidied up our code. So it's time consuming, but it was worth it. In terms of coding style, We did establish some guidelines early saying these are going to be our coding style guidelines. We did not follow them consistently. We've now kind of gone back and we finally declared PEP 8 to be the standard for code and documentation, with one controversial aspect, which was the fight over 80 columns. So I think we've bent the rules, and there's this loose agreement that you can use up to 120 columns. I mean, everybody has a 24-inch Dell widescreen these days. Dell is selling them for $600 at the normal price, and they discount them 20 or 30%. So everybody has a wide monitor. I think the bulk of our code still fits in 80 columns, but there are some cases where people want it to go wider. In terms of naming conventions, never mind the column width. Naming conventions was a huge battle. So the first earliest versions of the code, everything in there was prefixed with QBF, which was it was a code name for the project, So everything had a QBF this, QBF that in front of it. We then decided we weren't calling it QBF, so everything was changed to be Snap. There's no reason to do this. I mean, Python has namespaces. Most modern languages have some sort of namespace concept. So we ended up basically stripping that stuff. There are some places where we use a prefix where we want to differentiate between something that has the same name in the standard library just to make it clear, but almost all the prefixes are gone now. So for example, the code was littered with this thing called QBF resdef. It's now just resdef. It makes a lot more sense. There was no need for the QBF on it. We also, I think we overdid it on the _ private in the early days. Again, remember I'm taking some C++ and Java guys and they're coming up to speed with Python. So there was a tendency to use, I have a private in Python, I'll use it. So everything became _ private. I really don't understand the major negative impacts of that, but it just started looking ugly, if nothing else. It just didn't look good. So now we're using the advisory _ private. I do remember we ran into some things with the mangled names because of the double underscores, but I don't remember exactly what the scenarios were. We also have guidelines for lowercase, camel case now, and when we use upper camel case and so on. So there are some guidelines. I think what it boils down to is classes are camel case names, attributes are lowercase names, and we seem to be leaning towards lower camel case for function names. It's working, and it's consistent, which is probably the big thing. Also, we have a German working on the project who often corrects me that this isn't really the way a German would assemble a name when you deal with the noun concatenation rule. But the reality is some of the names in the code were really, really, really long. And we've gone back and revisited those and tried to shorten them down. I mean, you can always get into debates over abbreviations, but some of the stuff had really gotten silly. And I can't exclusively blame the German guy. Some other people did it too. We found imports get out of hand quickly. Again, this is more discipline. Various files in the system would start doing imports, and they were in kind of a random order. We had at least one case where we had circular imports that were a pain to get out of there. So we started following a discipline, and the current discipline is that we basically import the standard Python library modules. Then we import third-party packages, things like PySQLite, PyMySQLDB, RDFLib, and so on. And then we pull in our packages or modules. And that ordering, we typically put it in 3 blocks with a blank line between each block. That seems to help. We haven't got fanatical about ordering the individual lines. It's really up to the individual programmer. But we did find imports got out of hand very, very quickly. I think a last point here on just generally coding and coding style. There is a tendency to try and write Java or C++ in Python. There's this little blog post out here at dirtsimple.org called Python is Not Java. And it really does a good job of summarizing some of the things you see a lot in Python code written by Java programmers. Some of the things we bumped into. One thing is this business of being able to add strings. This is the holy grail for any C programmers. I can take strings and I can just glue them together. So we found, these are extreme cases, but there were instances where we had a string and we had string equals string plus new value and just continually concatenating into a string. It's a very expensive operation because strings are immutable. If you want to make a string of length 10 x's, 10 times x. Very simple way to do it in Python. More importantly, though, it takes a while for people to get the hang of this null string or just the string join idiom to take a list of strings and join them together in one shot. So if you're building up, in a lot of cases, if you're building up something like an XML document or an HTML document where it has to be built in a custom way, It's more effective to just basically take the strings you're generating dynamically, append them to a list of strings, and then join the whole thing at the end.
Obligatory comment about, don't forget about C string IO, because then you can use it, it does that list join behind the scenes while exposing to you like a file object, f.write.
That's a good point. You're not on the mic, so I'll repeat that. The comment is, don't forget about C string IO, where you can get a file-like object, and you can write to that and assemble these buffers as well. But I think the important thing to me was, don't do this. Even in smaller cases, it's just so wasteful. It makes a lot of sense to try and treat things as a list naturally. We didn't have too much of this in the code, but these are idioms that started creeping in that we managed to get rid of very, very early. Something that did creep into our code a lot was the getter-setter model, where people write little functions to get a variable or a set a variable, and the function does nothing other than assign to a private member. I mentioned the double underscores. So, the first thing was the double underscores, and then the second thing was, well, this is private, but I need to control access, so now I have a getter and setter. I don't know where getters and setters started. I came from the assembly language C high-performance world, and nobody ever wrote getters and setters. So I think this originated in the days of VB. It got very popular, and it kind of caught on. I've never liked it, but in Python, you have property. So if you really do want to hook and control access, you can use property. If you want to get fancier, you've got getAttr and setAttr if you need to get very fancy. So I think almost all our getters and setters are gone. There's a handful in the resdef, but they're not really getters and setters around single elements. Also, everybody on the team now has a Python cookbook. They've all read them. They're getting pretty dog-eared, but it's a good way to start off and give people a solid foundation in some of the idioms. And this is what I mean. Another one I should have put on this list was David Goodger has a talk he's given on Code Like a Pythonista, which really focuses on common Python idioms, and that's been really, really good for people. He gave it at OSCON as a tutorial, and I think it's on the OSCON site. David Goodger, Goodger. I think it was interesting meeting him. I've known of him for years as the restructured text guy, docutils. Now, back to Eddie's topic, I think. A little bit of a segue here. I've been talking about code and kind of day-to-day activities, but I did want to shift over here and talk, when I was talking to Jim, he said, testing's always a hot topic. So, we're building all this code, and I talk about us kind of playing around. It wasn't quite as much wandering in the desert as it sounds, but we did need to start worrying about testing and a build process. So we currently have an automated build and test process. It's driven by BuildBot, which is another Python utility. You notice a theme here. We keep coming across these Python tools we keep using. Basically, BuildBot, I think there's a cron job that fires up every so often, looks for checkouts or looks for check-ins, and if there was a check-in within a certain amount of time, it starts the build process. You can also trigger it manually, so I guess that meets the Joel criteria of the one-button build. And the basic flow for the test is, the first thing we do is we check the code out of Subversion. We then have to actually go through a real build step. Python isn't compiled, but this flex stuff is, so there's some flex code there. We compile the flex code. Then we go off and we build an installer image. We use Bitrock for our installers. So we essentially pick up all this Python code, plus some third-party stuff we have to pick up, plus the flex stuff, and we build an install image. We then pump the install image off to a virtual machine. There are actually two here. There's a Linux and there's a Windows, but for the sake of this flow, we push it out to a virtual machine. We actually do the install, and then after we've done the install, we start running the unit tests against the code that made it to the target machine. So we go off and we run module-level unit tests. Then we go off and we run integration tests. And somewhere in that loop, I'm not sure before or after those two, we actually generate the epi-docs for all the code and API documentation. And it's interesting how much stuff epi-docs will trip over on formatting. It kind of forces you to keep your doc strings in shape. While we're going through that test process, we also check code coverage. We started off with coverage.py. We're now using Figleaf with some customizations to collect the code coverage statistics. And we do that while the tests run. Testing. Yes, unit testing, we've learned. When we started off at the beginning here, I think a lot of our early pieces of code that were really just little prototypes saying, here's how I think we could do this, they had a little piece at the bottom of the code that basically said, if name equals main, go off and run the tests. And the comment run tests was actually in the body of the code. There were no tests there. There were some things that checked syntax, and there were some things that demonstrated how you would use the API, but they weren't really tests. They were usage examples. And that caused two problems. The first thing is those tests weren't consistently run. Nobody was running them except the guy that was trying to come up with the example. Other people were copying them and saying, oh, that's how I use it without running the test. And the classic case of software rots. Either the code changed and the test didn't, or the test changed and the code didn't, but it didn't work. So now we've cut over. That didn't last too long, but we've now cut over, and we're just using unit test framework in the standard library again. So every module has a unit test that goes in a test subdirectory, and it runs the tests. We're starting to use PyMock a little bit to set up scenarios for cases where we depend on something, but you're always in that fine line of how much do you mock versus how much do you try and test in a real environment. But we are using PyMock for some things. I found with unit test, just forcing exceptions and simulating exceptions and pushing in bad values to tests, you can get pretty good coverage. So a lot of we're doing more negative testing where we try to break things with garbage values and make sure the right exceptions get raised, things like that. And they don't help you with coverage. So I think, moving forward, when I had written these slides a couple of months ago, I said, going forward. But I think as of today, we develop the unit test right up front. We're not a test-driven development where we do them in the beginning, but we are developing them much earlier on, and we're always checking code coverage during both unit testing and system testing. Yes?
Could you say a little bit more about unit test? Does it try to figure out what the test vector should be, or what's the
No. The question from the back of the room was could I get into a little more detail on unit test? Unit test is a framework that makes it fairly easy for you to write tests, assemble them into groups of tests, and have them all run through a consistent test harness. So it does a really good job of setting up a model where you can write code tests. You group them and you basically write your tests within a class. You have tests set up, you have test tear down, and unit test takes care of handling the errors. So you have functions where you can, I think one of the ones I use a lot is, is basically a raise assert, where you can call a function in your code and you can basically assert that that function should raise a certain exception. So unit test will take care of a lot of that for you. It will not figure out your test vectors or what you need to test. What works in conjunction with that, though, very nicely is either coverage.py or figleaf, which collects statistics while the code's running. It slows things down, but it does collect statistics while the code runs and lets you know which statements you executed and which you didn't.
So you mentioned that you're always watching this coverage. Is there a level, is there a red flag or?
I was hoping I could dodge that question. So the question at the back is, is there a level, is there a red flag? The ideal philosophy is 100% test coverage on unit tests. I think we've said we're aiming for 100%. Anything that's not 80 to 90% is we're paying attention to. It depends on how important we think the class is. There's always a judgment call. But a lot of the stuff at the unit test level is 80+%. I think, Aaron, I think a lot of it's getting up 90+ at unit test level.
Yeah.
It depends on the module.
There's a distribution of it, but there's a good portion of it that actually has 100%.
Yeah, and it does go up and down, but we're aiming for 100%. I don't think we'll ever get there for unit test. When I look at the coverage, the trouble is as you get closer to 100, if you miss a few lines, you're way off. So the beauty of the figleaf stuff is it gives you a nice formatted report showing you the code, and the lines that weren't executed were in red. So you can kind of see and you say, yeah, I really should fix that coverage, but on the other hand, it's not going to get tripped until the next time you hit a bug, and then there's going to be that piece of code.
You're using a lot of great libraries like PyMock and figleaf and BuildBot, but I noticed you're not using nose or pipe.test, and I'm just wondering if you had anything to say about that.
Yeah, Jim. Oh, repeat the question. The question was we're using all these great modules like unit test and figleaf and BuildBot and so on, but we're not using nose, or what's the other one?
Or pi.test.
Pi.test. I'm not at all familiar with nose, so I don't know what benefits it gives us. I think part of the answer here was At our unit test level, most of the tests tended to be pretty straightforward in terms of exercising code. The bulk of our testing kicks into gear at a higher level, which is more integration testing. And I don't know if Nose will help us with this stuff. I've heard of Nose, but I really don't know what benefits it has.
Discovery, so you don't have to write so much bootstrap, and you don't accidentally forget to add like one of your submodules to the parent so that it gets included in the suite.
Oh, okay.
Discover all the tests in your system.
Oh, okay.
Start using it actually without changing very much.
We could potentially be using it because this stuff kind of magically appeared one day. So I'm going to repeat. The comment from the back room is that Nose will kind of auto-detect the tests and help you set a lot of this stuff up and deal with running them.
Is that the KNOWS or NOSE?
I think it's NOSE. NOSE, right? Nose. So integration testing is our next level. And this is really kind of system level testing for us. Way back at the beginning of this talk, I was talking about how we were doing this data integration framework. So we connect to databases, we connect to files, we connect to other servers. We require a lot of infrastructure to exist before we can get a real test environment going up. So after we do the unit tests, we go through a series of integration tests where we try to deal with the connectivity matrix and execute different scenarios. And while we run these tests, we also verify code coverage. One of the reasons we're doing the coverage checking is with Python, it's possible to have a typo in code that's never been executed and you trip it at runtime. That was actually one of the open source bugs we found. There was a line that was munged in the code, you know, and it's like, okay, we hit it at runtime. It's like, okay, what do we do with this? Because you get a syntax error. And also unit testing, I don't know if this is a proven fact, but at least it's my opinion. I know unit test will never cover all our code. Even if it did cover the code, it won't cover all the permutations. So that's why we keep running the coverage stuff. And we modified Figleaf to do cumulative coverage so that we collect coverage stats during unit test and during the integration tests, but we also have this aggregate coverage across the two. And that makes a difference because we can see if we didn't hit it in unit test, we'd probably hit those lines of code in system test. I don't know what the status on those fixes are. I think we're handing them back as soon as we're comfortable with them. On the client side, I mentioned a client GUI. We have this Flex browser client. That's not automated. It's basically manual testing, and it is a pain. One of the difficulties there is it's not really a forms-based client, so you really have to come up with scenarios and run through them in the client, and it's a lot of extra work. So that's definitely one of the areas that needs more work.
In your discussion of toxic waste, you had an excellent suggestion that your fixes are well received if you send not just the bug, but the fix and the test that proves that it's there. Now, one of the things I heard longer ago than I care to admit was a company that was developing software, and the rule there was if you made a change to a module, you had to write a test that proved that it wasn't working before you fixed it, and thus it worked after you did so. Just a thought.
It's an interesting. So Drew up here, I'm going to try and paraphrase the question because it was long, but what he's saying is we had the suggestion that you're more likely to get an open source bug fix if you submit a fix in a test case, and then he was commenting on the statement that in one organization there was a rule that said that if you were fixing a bug and there was no test case, you should write the test case that demonstrated the failure and do the fix at the same time. I don't know if our engineers want to go back and write test cases for code that they didn't originally write, but it is a good rule. And we're trying to get to that point. I think Python makes this easier, in my opinion. I've done an awful lot of programming in C where I didn't write a lot of test code. Somebody else worried about test code. I find with Python, we're more likely to put the test code into the core code. So I was switching gears here a little. How are we for time, Jim? Are we running late, or? I think we got a couple of slides left. Okay. So, you know, again, switching gears, getting away from kind of the test infrastructure, one of the things we wanted to do was have a pretty good installer. So we needed to deal with this issue of packaging and installs. So we use Bitrock as our installer. It's actually not open source, but it's a pretty popular product among open source companies. And the Bitrock installer gives you an executable that runs on either Windows or Unix and is supposed to do the rest of the install. And it's like any other installer. There are weird config files that let you program the install. The Bitrock installer, when you run it, we'll go off and download other eggs for other packages that we depend on directly from the cheese shop. So actually, it's not the cheese shop anymore, right? It's now the Python package index. But anyhow, it downloads the stuff and sucks it all in. And that way, we don't have to worry about distributing older versions of those modules, and we can build in the version dependencies. We do have dependencies in a lot of other packages. I mean, our core stuff is sitting on top of, take, for example, it sits on top of RDFlib, which in turn sits on top of either PySQLite or MySQL DB, which in turn sits on either SQLite or MySQL DB. And that's just one piece of the code. Then you have connectors to various databases and various files that depend on a lot of other modules. So things get complicated. We're not creating RPMs or DEBs right now for the distribution. We're just doing this install image. We might do that in the future. The trouble is that the RPMs or DEBs tend to be very system specific. So I'm trying to cross my fingers and hope that somebody creates generic RPMs for us and we don't have to do it. The biggest install problems we've run into, I think the number one issue has simply been that we want to see a Python interpreter installed on the system before we begin the install. So we could fire off our BitRock installer, but it's going to go out and say, what version of Python do you have, and start running from there. We didn't want to redistribute and install Python. So that's kind of an issue that we need to have a Python installation to get started. It's not an issue for a developer. It will be an issue, I think, when we get a little away from the developer and start introducing people to Python. A number two issue, or number one, depending on how often you bump into it, is vendors that distribute really old versions of Python. I think my biggest offender here was Red Hat with Enterprise Linux 4. I mean, they shipped Python 2.3. I think it was a 2.3.1. So, okay, so they ship a fairly old version of Python. The problem is, I mean, there are issues. I don't think we're even running on Python 2.3. There are some issues in the libraries that we can't get around. The trouble is you can't easily upgrade that version of Python, because you go upgrade that Python. There's a bunch of Red Hat stuff that depends on that Python. Then you find that Apache depends on it because it's using mod Python. So you upgrade MyPython, you have to upgrade Apache. Upgrading Apache means you have to upgrade PHP. And suddenly you open this big can of worms of dependencies. So our solution has really been, in cases like that, my recommendation to anybody is just leave the old Python there, put another version of Python in user local or someplace like that, or run your own private version of Python. And that's been a good solution. The downside of that is in some cases, somebody needs to have extra permissions to do that install. And again, for the developer that owns their desktop machine, it's fine. But as we start getting away from the core Python users, there's that little extra hump to say you got to get Python installed that scares people away. The current Python installers are pretty good, just from python.org. I did an install on this MacBook about 2 months ago, just before OSCON. It was the first time I've done an install without downloading and building from source code, and it just installed. So there were no issues there. And I think that's also true of the Windows installer now. We have another issue that's much stickier. I listed it here as dependence on database libraries, but I think it's more dependency on just modules that use C. So, for example, SnapLogic wants to connect to MySQL. So there's a Python MySQL package. That's easy to install. But that package, in turn, has a couple of pieces written in C that have to be compiled and linked against the MySQL library. So that opens a can of worms. If you're a Linux developer, you got a Linux box, you have all this stuff. It just goes right through. But you'll find there's a couple of curveballs you hit. The first thing is you need the C compiler. Everybody on Linux has one. People on Windows don't. The second thing is for cases like MySQL, the Python MySQL library, the code that's in there, the C code that has to be compiled, has to be linked against the MySQL development libraries, which again may not be on the machine that has the MySQL server. So there's a little bit of complexity there. We do whatever we can to check the prerequisites, and we found as long as you get the right development packages and development headers installed, everything works. Another aspect of this, sometimes we bump into this on even on Unix, where some of the RPM distributions split this special package they call Python devel, which essentially includes some of the conclude files. And a lot of these C extensions depend on having, I think it's mainly python.h, the header files. So you do hit that problem, and I think that's really going back to the vendors and saying, hey, stop doing this. Just put all the Python stuff there and stop splitting it. That would really simplify life. On Windows, we don't have a solution for this. What we do on Windows now is ship binaries for some of those things like the MySQL libraries, because there's no way we can look at somebody and say, you need a C compiler. Go install Cygwin and give us a call back. That's not going to work.
Why doesn't install Cygwin work?
It does work, but it assumes, the question from the back here is, why doesn't install Cygwin work? It works, but I find that on the Linux world, if you tell somebody, go install the Python develop package, you give me a call back, no problem. When you're dealing with the Windows desktop, a lot of people trying this stuff on Windows, they don't want to install Cygwin. They can install Cygwin. You know, it tends to be a different environment.
That's not even really a great solution either, because then you're dependent on the Cygwin Python.
Well, you can.
Yeah, I mean, there's a deeper issue there.
Nasty trying to compile stuff.
Yeah, I think the comment from the back here,
But it's not true.
it's not true anymore?
Great package of MinGW made by an Italian friend of mine, Giovanni Baio. It's a 4.1. It's not the 3 crazy that the Cygwin people are using. And it's still, it builds you code just as good, well, almost as good as you can build with Microsoft. It's 5–10% slower than you can get with a Microsoft 1003. But
That's with yeah.
it's a package, so you don't need all the rest of Cygwin. It's really much smoother. You should really check it out. It was announced on Python months ago.
Yeah. Anyhow, that's a good point, though, that you can get, it's just the MingGW, the plain distribution, not included in Cygwin.
Not the standard one. That's far too slow and
Okay.
crunchy. You need the one that was announced on Python announced.
Okay, so it was on Python announce. I don't know how to repeat the question, Jim. So I think that the question that came up here really has to do with the C compiler on Windows. You know, how do you get somebody to install a C compiler? And I think the options are either Cygwin or the one that Alex mentioned here, which is a good port of a 4.x port of MinGW, which is a good compiler. I think both of those work. The problems we've bumped into in the area of C compilers is, number one, asking somebody to install a compiler just so they can install your product. It usually kind of shakes them up a little bit with, no, we don't want to do that. So if it's a developer, it's not an issue. If it's not really a heavy-duty C developer, they usually kind of, why do I need to install C? The other issue we've bumped into, and I don't know the current status on it, is when you're dealing with Windows, the different compilers create binaries slightly differently. And you run into some subtleties where if you have MySQL runtime libraries that were compiled with compiler X, you can't compile the C extension with compiler Y and make them work together very nicely. And that's been the bigger limitation on Windows.
Almost sounds like a candidate for a virtual appliance.
So the comment was, sounds like a candidate for a virtual appliance. It is a candidate for a virtual appliance. We just haven't been able to get the download side down small enough to make it manageable. Because the SnapLogic stuff isn't that big, but when you bring in the MySQL footprint and some of the other things, it can get fairly big. But we've actually played with that. We actually have them lying around, but they're too big right now, even compressed. But I'm going to follow up on it in the future. You had another question?
No, just to finish up. So it's basically a social engineering problem. People on the Windows community are just picking over compiling.
It depends on the audience. I think the comment is it's more of a social engineering problem, and I think that's true. For people that have downloaded SnapLogic, most of the downloads have actually been on a Windows desktop, but it's been more people playing with it than people looking to hack at it and kind of build serious integrations. People saying, oh, this looks cool, let me try it on Windows. They tend not to have a compiler. There's another aspect that comes in here. I think it'll...
I'm sorry. No. So why don't you make a precompiled Windows version side by side to the source?
What we do right now in the installer is we provide all the precompiled stuff. So our installer, it's not an issue for us in terms of the packaging and distribution. It's more something that we had to solve as part of building the install. So we had to go through all this stuff. It's basically resolved. If you take the download image, it does everything you need it to do. It just sticks all these binaries on. It's just more work at the back end for us on the install. So I think my statements here about the biggest install problems, these are things we had to deal with as we put together the install. They're not really issues we keep bumping into. I probably didn't make that clear.
But for the Linux, I can see it could be a problem because the average Linux user user will not want to get mysterious precompiled binaries. They want it recompiled from sources. So I can
Yeah.
see that if
And the
Python devel is hidden somewhere and so on, that could be a problem.
So on the Linux install, we basically just go out to the package index and we do the dereferencing and we just download the packages. The only risk factor there is a site might be down and we might not be able to install it, but that's not a big issue these days. So the Linux installs actually pull most of the other packages down and do the local compiles and links. On Windows, we've bundled up all the binary pieces we need and included it in this one big install image.
Should you ever support the Mac, remember that while the compiler is free, it's 1.2 gig download. The C compiler comes only as a part of Xcode, which is a
Yes.
1 point something gigabyte download.
Yeah. So Alex is making the point on the Mac, and it's running on the Mac. I have it running on mine. We just haven't done the install image. And the secret, there's two secrets. One is to remember the size of Xcode, and the second thing is it's actually on the Mac CDs, but they put it in a place where you have to remember to scroll down in the installer to go find Xcode to install it. You figure Apple will put Xcode on the top so everybody installed it. And another issue while we were talking about installs was, for example, with Windows, we tried the Windows Vista install. We've done a test on it. We were able to get through the install and it all worked. It just, every time we did something, you had to click through the entire sequence of this program wants to do this, this program wants to do that. It was just a very difficult install because we're going out and downloading this stuff from the network and doing this and doing all these pieces. The Vista install just didn't like that. It worked, but you had to click all the right yes or no's. So I think we're running tight on time here, Jim. Should I go through? I think I have 2 slides left here that I wanted to touch on. So in between all this product stuff, the other trouble with open source is you now have to get a site up. So there was a whole separate process here, which was building the snaplogic.org site. And again, no surprise here, there's an awful lot of Python and open source stuff out there. So the main snaplogic.org site is running on Red Hat Linux, just a machine I lease in a data center. It's Apache and mod Python, and I think it's now mod WSGI. I think we cut it over to mod WSGI. Python 2.4.4 is running on that machine. It's running track 0.10.4. Track is not a version 10 yet, I'm sorry. It's track 0.10.4 with a MySQL database. If you're running track, stay away from MySQL unless you're ready to do some debugging. It's not quite there yet. The SQLite stuff works. We've hit a lot of issues with the MySQL stuff. So again, it's kind of fix it, ship it back to the track team. Mailman runs the mailing lists, another Python package, no problems with that. The blog is WordPress, which, yes, it's PHP. We initially started with some Python blogging software called Newsbruiser, which is a pretty nice package, and it has this wonderful feature that it supports restructured text. Unfortunately, nobody but me liked it, so that was a down, and we settled on WordPress. It's fine, it works. The PHP stuff's in Apache, and I think every time you install WordPress, you have to touch the code, so it's not a big deal. We've started using Django. We have a piece of our site called packages.snaplogic.org where we're beginning to collect content, things like resource definitions and extra plugins for the system, and we built that using Django. And that was pretty painless. So we'll probably keep using more Django on the site. For future tasks, we're currently using Track as the bug tracking and wiki together. I'm not sure if the wiki is going to stand up to the loads and some of the security issues, so it's pretty likely we'll cut to something else. Okay. No, we don't have SnapLogic running on that server. SnapLogic is more a data services ETL product. So we've got it running on another server for some sample cases where people can consume data services. But we're not using SnapLogic to maintain this machine right now.
Do you use it for anything that's critical to your work?
Not yet. Not yet. But as we come up with those things, like one of the things we're working on is some reports out of Track. And for things like that, we're using SnapLogic to do some of the extracts and do some of the statistics out of Track. But it's not mission critical for us right now. It will be eventually. Keep in mind that there's one machine in the data center, and there's machines on developers' desktop, and there's a mail server in the machine room. So we don't have a lot of data integration stuff going on yet, but we will have in the future. So you had made a comment from the back that version 11 of Track will have, or 0.11 will have better security.
Yeah, Alan Thomas implemented like this whole like ACL type security.
Okay. Yes, so Moin Moin has a lot of that functionality today. In Track, it's not there. We're using Track right now, and I think it's kind of lightweight, but it's starting to grow up pretty quickly. I think there's enough people using it that it's really getting hammered into shape very, very quickly. But again, you know, Moin Moin's an option. On the website, there's a static website that just has some pages up there. And as we're going forward, we have to decide whether we're definitely going to something more dynamic. So the question is, you know, do we look at Django? Do we look at something like a Zoplone? Do we look at something else like a Joomla, which is PHP? But just get a better content management system out there. Haven't done any real research on this, except I know it's somewhere out in the future. We may just go to the wiki mode and forget about the concept of a static website. You know, that may work better. On the project itself, coming up in the future, a lot of stuff to do. You know, one of the things we're paying attention to already is Python 3000 support. We were late with Python 2.5. We didn't prioritize it. We didn't try against Python 2.5 till it was late. Mostly we found that the issues we bumped into were just some dependencies and having newer versions of packages. And we found that when we did go to Python 2.5, we actually had to wait for some of the third-party packages to support 2.5. It was little things like that. So hopefully Python 3000, definitely a bigger upgrade, but if we start paying attention to it up front, it shouldn't be an issue. On our server side, I talked about this HTTP and the streaming stuff. And on that side, we're probably going to cut over to WSGI. We're currently testing it and seeing if we can make that do what we want. In the early days, we just wrote our own HTTP server because we needed to get rolling. On the performance side, we're definitely compute intensive when we start firing off these components, so performance is an issue for us. We're still mainly single processor, which has prompted some people to kick out blog posts about this. We do use threads. In fact, I think we use too many threads given the way the Python interpreter manages things. I think we fire off more threads than we need to, and we're not getting parallel execution from them. We're probably hurting ourselves a little. But we are looking at parallelism in the broad sense, whether it's process level, probably more process level in terms of taking HTTP requests and trying to dispatch them to independent processes, potentially message passing using a PyPVM or something like that. But something's going to happen in this area. We're doing the homework. I don't think we've got all the answers yet.
You did get my suggestion yesterday to just try use third-party module processing instead of standard module threading. The interface is just about the same, but I'm not sure if it's true it's on a dual processor, but on a quad processor.
Yeah. So Alex is mentioning the library where you can import process instead of threading. Processing.
Like threading.
And so instead of threading, import processing, which he mentioned in his talk last night, and that'll help. Yes?
Yeah, I was wondering.
It's not part of the testing process yet. The question, I keep forgetting with this microphone. I'm sorry, guys. The question is performance profiling part of the testing? Only to the extent that we're looking at the timings on the tests. We are cutting a release the end of this month, and as soon as we finish that release, we're gearing up to do a lot more kind of benchmarking and reference testing and performance, not even at the profile, but just kind of core level benchmarking on the product to make sure that we get the performance up there. But we haven't gone in and done low-level profiling yet. I mean, at this point, we pretty much know where the issues are, and I'm being honest when I say that. We know where the issues are. Once we get the first cut of issues out of there, we'll have to start doing some profiling. So parallelism definitely on our horizon, whatever solution. And I have a feeling there'll be multiple solutions here, one for the local machine and one for distributed across machines. There'll be different strategies. Also, kind of an ongoing thing for us, and the reason we really built this open source is the notion of connectivity. You know, we have some drivers for core databases, but over time we want to address a lot of different data sources, so there will always be more connectors and more components in the pipeline. I thought it was worth mentioning here. I always get beat up by the Perl folks talking about Perl DBI, because Perl DBI has a driver for everything, including some things you wouldn't even think there would be a driver for. The Python database API isn't quite there yet. It covers the major databases, but I think over time it's going to get fleshed out, and we'll probably end up doing some work in that area as well. So there's a lot to do for the project, and again, before I forget, we are hiring. We're looking for real Python wizards if anybody's interested. It's an ongoing project, and by all means, check it out, download it, and see what you think of the SnapLogic stuff. There was a topic here. It occurred to me. I think this is the last slide, but there was a topic here I didn't bring up before we get into questions, and I thought it's not a Python thing, and I really wanted to concentrate more on Python-centric stuff, but documentation. Just a whole different project to get documentation on what we have and how we do it is just an ongoing thing. And it reminded me, because the Python team is redoing the documentation. I don't know if everybody here knows it, but there's a plan in place to redo at least the tool chain oriented around the documentation. And they're open to suggestions and some of the things people might want to get involved in. So, questions? I think, yes?
One thing that's not very Python oriented, but you didn't mention at all, is what's your business model?
Oh, okay. So the other question is, what's the business model? So right now, the focus for this year has very much been building out the product, building out a community, and really kind of working on the install base. If we can get enough users of this and really prove that it's generally useful, the business model will most likely be a services and support model. Very similar, I think, to MySQL, where the core product is free, and if you want support and services and so on, you need it. For the individual developer that just needs to do what I like to call data munging, I'm stealing Greg Wilson's term, but for people that want to do that, I'm never going to get any money from them anyhow. I'm not even going to try. The product's free. For companies that have a lot of these, when you get into the enterprise, there's a huge amount of point-to-point data interfaces. I've built a lot of them myself in my former life, and they get out of hand very quickly. So there are companies that are happy to use a framework and pay you for some level of support and services to try and manage that. So that'll be the basic business model. There are other opportunities. We could do things like host data services and so on, but I'm more interested in finding somebody else to use our stuff to host data services. I don't want to run the infrastructure. It's a commodity now between S3, and you've got S3, you've got EC2. I'm sure I got Google Base. There's so many places where you can host data. I don't want to get into that business.
On
Yes,
the
Shannon.
topic of business models, since you're talking about your business model, I'd like to recommend Founders at Work. It's a book, so you can read the sections on Ars Technica and Joel on software, and they had similar business models. There's about 3 companies that did the same thing. It's nice to just run through, just get some experience on how it worked out, because it does work out really well sometimes.
So I don't know if the mic picked up Shannon, but he's recommending Founders at Work, which is a summary of some other successful companies and how they started up with similar business models. But the basic, I have this is getting away from Python, but I have this belief that, repeatedly, every place I look, the price of software is slowly but steadily going to zero. On the license side, not on the manufacturing cost, but on the license side is going to zero. Software as a service is one way to try and kind of, I almost think of it as an attempt to add value and justify the cost of that software, but it is coming down. Appliances are another way. If you give somebody something tangible, it's easier for them to cough up a license fee. But in reality, if you look carefully at the financial records from a lot of the software companies, you'll find that they sit, 60-40 between services and license, or 50-50. But if you look at the margins are on the support and services. Nobody makes money on software licenses, especially if they're in the enterprise market and they're actually trying to pay the sales guys the commissions and look at the cost of sales. So cost of software is being driven down quite a bit. Open source has had an impact on that and other trends. But services and support is really the basic business model. And that's what you see among a lot of the open source companies. Most of them have really moved to that model.
Well, that's great, because it finally justifies having buggy software.
Finally justifies having buggy
We
software.
always have buggy software.
Yeah, so it's an interesting comment. Yeah, in the past people felt guilty. The other aspect is, if the code's out there, the bug fixes get fixed. I mean, I've dealt with enterprise software where I hit nasty bugs that, you know, I can understand how they could slip through QA and a vendor could release it. That's just, it happens. But the trouble was, once you hit this bug, the vendor didn't want to fix it. Even though I was paying them for support, they would not want to fix it. There was always a haggle over when do we fix it. So it's a different model in the open source space. It's a lot more fun in some respects. It's just harder to ramp things up. So Jim's, yeah, I think we have 2 minutes to 9 here. So were there any other questions? We need to start ramping up and doing mapping random access and things like that.
One quick last little question.
Sure.
Diagram, you had like a second slide, kind of your overall model of the application. Just noticed your Flex UI was talking to the management server with XMLRPC, and then that was going on.
Mm-hmm.
Did you need that for Flex to handle REST communication pretty well, or what was the?
Okay. It's gone way back to like slide 2. I think the reason was more history. The first release, I'll try and put the picture up here to make sense out of it. I should have also mentioned, these are on blog.snaplogic.org. I kicked up a blog post like yesterday with the slides attached. So historically, the reason is we were trying to be very, very pure about this being a very REST interface to the server. We're fanatical about that. On the Flex side, we found that we had to create these resource definitions in Flex. And what we ended up with was the actual Flex code does a lot of property set functions over here to this management server. The management server actually maintains that object. And then when you save it, he pushes it back. So really it became an issue of this thing was a lot of function call and, you know, kind of get and set property over HTTP, which we didn't want to put in the server. That was one motivation. It wasn't an issue with Flex in terms of capabilities. It was probably an issue with us learning Flex. This was the guy who developed this. It was his first shot at Flex, and it was definitely coming up the learning curve. And that part of the system, we actually didn't plan on a full user interface in the first release. We ended up doing it as in the first release, and we cut some corners to get that management server in there. Thanks, guys.